Welcome back, focused learners. Okay, let's dive right into this. We are looking at the absolute breakout technology of 2026, Causal AI. We're breaking down a fascinating white paper by IPE Services today, and it explores exactly how we take this brilliant, next-generation math and actually make it work out there in the real world, on the factory floor, the hospital ward, or straight across the enterprise.
So think about this for a second. What actually happens when AI moves from mere pattern matching to actual reasoning? This is the massive shift we're witnessing right now. For years, conventional AI has basically just looked backward. It sifts through mountains of historical data finding patterns and correlations. Sure, it could tell you what usually happens together, but it fundamentally couldn't tell you why. Well, Causal AI flips that entire script. It shifts the narrative from just finding correlations to uncovering true cause and effect. It brings actual reasoning to decision intelligence, and let me tell you, it's a complete game changer for how organizations operate.
Now, when you really compare the two, the contrast is just incredibly stark. Conventional AI relies on standard machine learning to answer a pretty basic question: what is associated with what? Causal AI, on the other hand, uses these sophisticated mathematical maps, things like directed acyclic graphs, to trace exactly how one event triggers another. You can almost think of these graphs as a family tree for your data. They show exactly what specific parent condition gave birth to a specific outcome. It answers a fundamentally different, way more powerful question: what would happen if we intervened? So it's the difference between merely noticing two things happen at the exact same time and actually understanding the hidden gears turning behind the scenes that cause them to happen.
Right. So why the sudden urgency? Why is this a massive boardroom priority right now in 2026? Well, there are four major drivers pushing this. First off, explainability and compliance. Regulators are knocking, and they increasingly require a defensible, transparent account of why an AI made a certain decision. A black box guess just doesn't cut it anymore. Second is agentic AI's trust wall. Look, as autonomous agents start making highly consequential decisions on our behalf, we need absolute certainty that their reasoning is mechanistically correct. Third, root cause discovery. This means pinpointing the true underlying driver of an anomaly, not just a symptom that happens to correlate with it. And finally, number four, scenario simulation. That's the ability to run virtual what-if tests without having to risk a costly or even dangerous real-world intervention first. It's incredibly powerful stuff.
But, and this is a big but, here is where we hit the wall, the major complication. Causal AI is statistically brilliant, absolutely. But it's operationally blind. As it's marketed right now, it's really just a data science and modeling layer. You could have a flawlessly discovered causal graph full of absolute statistical perfection. But the math doesn't know who owns a process. It doesn't know how to train your workforce or what shift is currently working. It is generally agnostic to organizational process ownership. It inherently lacks a human driver.
The white paper we're exploring hits the nail on the head with this quote. A causal graph can be technically correct and still sit unused if no operational framework translates it into standard work, training, and daily management. Think of it like a map versus the territory. Causal AI gives you this exquisite, high-resolution map of your data. It's beautiful, but it entirely lacks the actual territory of organizational ownership. Honestly, if no one is explicitly assigned to manage the nodes on that graph, nothing is going to change in your daily operations. Those brilliant insights, they'll just sit there, gathering digital dust.
Okay, so how do we solve this disconnect? Believe it or not, we actually need to time travel. We're going back 3 decades to the year 1996. That is the year Roger Slater laid down the foundational work for the Integrated Process Excellence Framework, or IPE. Way before the term causal AI was even a blip on the radar, Slater recognized that sustainable performance improvement required an explicit, traceable cause and effect structure. He was building the robust operational territory before the statistical map even existed. He completely understood that data without discipline was really just noise. And that operational territory is built on a really beautiful disciplined rule of 3. 1, 2, 3. You have key input variables feeding into key process variables, which ultimately produce key output variables, KIV, KPV, KOV. This 3-tier cascade organizes literally every single process at every level of a company, from a sprawling enterprise area, down to a specific activity, right down to the individual operational element. And what is truly stunning here is how this operational chain perfectly mirrors the mathematical nodes, those ancestor-descendant relationships that you find in a modern causal graph. Let's break these down a bit, because this is where the operational magic actually happens. First up, we have key input variables, or KIVs.
These are your upstream conditions. We're talking raw materials, technical specifications, equipment readiness. Now, in causal AI terms, these function exactly like your root or parent nodes. They are the controllable, measurable causes that get fed right into the start of a process. And look, if your inputs aren't right from the very beginning, the whole downstream system is going to inherit that flaw. It doesn't matter how amazing your team is, bad inputs mean bad outcomes. So, the crucial point here is the key process variables, the KPVs. These are your in-process parameters, the critical control points. If KIVs are the parents, KPVs are the mediating nodes. This is the exact mechanism where a KIV's effect is actively transmitted, monitored, and, this is key, corrected in real time. This is exactly where human accountability steps in. It's the operator tweaking the machine temperature, or the nurse adjusting the workflow. It's controlling the process before an outcome actually goes off track.
And finally, we hit the end of the chain. The key output variables, or KOVs. This is the stuff leadership actually cares about when they're staring at a dashboard. Quality, cost, delivery. These are the sync nodes, the end effects used to judge if a process is truly under control. And the IPE framework perfectly closes the loop here. It ties these KOVs directly back to standard industry metrics using master KPI mapping tables. So the causal chain is complete. It's fully traceable from the initial, humble input right up to the executive business scorecard.
Now, you might be wondering, okay, is this just some theoretical framework? Is this just consultant speak? Absolutely not. Let me give you a number, 81. There are currently 81 sector-specific IPE packs fully deployed out there in highly complex industries. We are talking critical environments: healthcare, heavy manufacturing, steel production, pharmaceuticals, precision plastic injection molding. Each one of these 81 packs represents a massive library of process knowledge. It just proves that this operational causal architecture isn't some blank slate. It's already heavily populated with thousands of real-world, battle-tested KIV, KPV, and KOV examples rather than just generic variables. It's essentially a plug-and-play operational brain ready for an AI to connect with.
When we pull back and look at both of these paradigms together, we see this really fascinating synergy. Causal AI offers a powerful, general-purpose mathematical language. It is statistically brilliant at discovering hidden causes across basically any dataset. But the IPE hierarchy, well, it's pre-populated, it's sector-validated, and it operationally assigns ownership and control. Causal AI answers what is the cause statistically, IPE answers what is the cause, who owns it, and how is it controlled operationally. So you've got raw, unbridled data science on one side and essential human deployment discipline on the other.
And this brilliantly illustrates exactly where they align and where they diverge. Take their core structure. Causal AI uses a directed acyclic graph, right? While IP uses that three-tier cascade. They both map causality perfectly, but consider their primary questions. Causal AI asks, what if we intervene, while IP asks, what must be controlled? And as for explainability, causal AI gives you a model-level explanation, but IP gives you a process-level explanation, and it ties it directly to a named human owner and a specific control point. So they absolutely converge on the first principle that correlation just isn't enough, but they diverge powerfully on the need for true organizational governance.
Which brings us to our final provocative takeaway for any operational leader investing in this technology today. Are your causal graphs actually anchored to an operational architecture? Or are they just statistically elegant models that never translate into controlled processes? Look, if you don't connect your incredible data science artifacts to a process-level architecture like the KIV-KPV-KOV hierarchy, you risk building super expensive maps with absolutely no one to navigate them. It is a really powerful challenge from the source material to make sure causal insight actually translates into daily process control. Thanks for joining me on this explainer. Focus learners, keep learning, keep questioning, and I'll see you next time.